In the previous video, we have studied about limits. What really limit is and how can we evaluate limit. Here I will continue with that topic, and here in this video we're going to find different limits for different functions. First, we'll find a limit that exists. We have taken a function y is equal to x squared plus 2x plus 2. I've shown you the graph for here. This is a kind of continuous function, as you can see in the graph. Now, graphically, how can we find the limits? For example, we will have to find limit at x equal to 4. If we see closely at a graph and if we focus on the point x equal to 4, we will have to we have to approach 4 from right side and to the left side. We will see how it behaves. For example, when we are approaching 4 from right side or left side, we can see that the corresponding value is approaching to the value of -6. That is here, from right side or left side. So we can say that graphically the limit of this function is equal to -6. Now, how can we evaluate the limit with the help of a table? We have this function. First, we will take the values that are closer to 4 from left side. For example, we will take the value 3.9, 3.99, 3.99, and we can come much closer, for example 3.999, and we will see the behavior of the function. Here, for example, you want to find limit at 3.9. You'll replace the x value with 3.9. And you can see that the value of function is equal to -5.4100. And if you come more closer from left side, that is, you will have to put, for example, 3.99. When you put the value of x as 3.99, you will get the output or value of function as -5.94010. So like this, if you're approaching more closer to that of a value 4 from left hand side, for example 3.99, on putting the value of x as 3.999, the function is generating a value that is equal to -5.99400. We can observe that on moving from left hand side, okay, and we are approaching closer to that of 4, number 4, the function is approaching to a value that is 6. That's almost that's almost equal to 6. So similarly, what we can do is we'll try to come to value of x equal to 4 from right side. We will take the value that are closer to that of 4. For example, 4.1. Coming more closer, it will be 4.01. Coming more closer, it will be 4.001. And we can see that the values are getting closer and closer to that of a value 6. As seen from the graph and the table here, it's plausible that the left hand side limit is equal to -6 and the right hand side limit is equal to -6. So we can say that limit as x approach to 4, the function will generate an output that is equal to -6, or we say limit of this function at x equal to 4 is -6. In the next example, we do have a function that is discontinuous. You can see there is a gap between two, and this is a piecewise function. So this is a part of x squared, while this line is -x plus 6. It is not defined at x equal to 2. You can see that the function is defined for x less than 2 and x greater than 2, but it's not defined for x equal to 2. If you want to find limit, for example, for this part, if you want to find limit at x equal to 2, then we will have to take this function, that is x squared. So we can find the limit. For example, we will take the values that are closer to that of a 2 from left hand side. We will take values that are closer to 2. First we will take value as 1.9, then 1.99, then 1.999. I will take a general point, for example 1.99. We will replace the value with 1.999, and the value that I'm getting is 3.99600. Similarly, if you want to approach x equal to 2 from right side, this time you're gonna take function -x plus 6. Okay, because it's mentioned over here. So for example, you can take values that are closer to that of a 2, that is 2.1, 2.01, 2.001. For example, if I take as 2.1, I will substitute the value as -2.1, and computing it will be 3.9000. Similarly, we can take the values 2.01 and we can take the values 2.001, and observing this, we found that from left hand side and right hand side, the values are getting closer to that of a number that is equal to 4. That means the left hand limit is equal to 4 and right hand limit is equal to 4. That means if we want to find a limit at that particular value, for example 2, the limit value will be equal to 4. Remember that function is not defined at x equal to 2. We only have to take values that are closer to 2. Either you approach it from left side or you approach it from right side. We will take an example where the limit does not exist. You can see this is a type of function which is discontinuous. There is a jump discontinuity over here, and this is a piecewise function. That means this part is x plus 2 and this is -x plus 10. X plus 2 is defined for x equal to 5 or lesser than 5, and -x plus 10 is defined for x greater than 10. We can see that from graphically. If you want to find limit, for example lesser than 5, we will have to come from left hand side, and we can see that the corresponding value that we're getting on y-axis, or the output that we're getting, is equal to 7, almost near about 7. And if you approach it from right hand side, the corresponding value that we are getting is 5. That means left hand side limit is 7 and right hand side limit is 5. We have seen it graphically. Now if you want to find it with the help of table, you'll take the function. If you have to find the limit, for example, you have to find the limit for x equal to 5, you'll take the values lesser than 5. For values that are lesser than 5, we'll have to take the function fx equal to x plus 2. And we can take the different values that are near to that of a value 5. For example, here I can take values, for example, 4.9. The output that I'm getting is 6.9. And if you take 4.99, the output that I'm getting is 6.99. If you come more closer, that is to that of 5, 4.99, the output that I'm getting, or the limit that I'm getting, is 6.99999. Similarly, if you come across, if you approach x from the right hand side, that is x, that is we have to take the values that are greater than 5. For example, 5.1, 5.01, 5.001. That time we have to take the function fx equal to negative x plus 10. So you will put the values. For example, I want to find for 5.001 the value of function for 5.001. I will substitute the value, that is negative 5.001 plus 10, and on computing we're getting the value 4.999. In the first table we can see that the value is getting closer and closer to that of a number 7. In the second table, when we're approaching from the right hand side, this is from left hand side, this is from right hand side. Okay, the values are getting from left hand side, it's approaching to that of value 7, and if you see it from right hand side, the value of function is getting closer and closer to that of value 5. Here from the table and the graph, it appears that as x approaches to 5 to a number less than 5, we're getting a limit that is almost equal to 7. And if we approach 5 from number greater than 5, that is from right hand side, we're approaching a limit that is equal to 5. That means the left hand side limit and right hand side limit, they're not equal to each other. So in this case we say limit does not exist, because for us one input value we cannot predict what the output is, if it is 5, if it is 7. So in that case we cannot tell anything about the limit. Okay, so here in this case we couldn't find the limit of the function, because left hand side limit and right hand side limit are not equal. Now for the next problem, I'm going to take again a limit, a function for which a limit does not exist. I will take a function 1 by x. We know that here in the graph we can say this is a discontinuous function, and it forms an asymptote at x equal to 0. That means if at the value of x equal to 0, the graph never touches the y-axis. If you want to find, for example, even the graphically you can see that if you are taking the point 0, okay, near about 0, from right hand side we are getting some positive value. Okay, and from left hand side we're getting some negative value. Here in the graph we can see limit of the function from left hand side and right hand side, they're not equal. They're different. Even we can do it from the table, by the table. For example, you can take the values that are lesser than 0. For example, negative 0.1, negative 0.01, negative 0.001, and you can observe that a function generates a output. In the first case, it's negative 10, negative 100, negative 1000. That means as we are coming much closer and closer to that of a value 0, the output is getting smaller and smaller. That means we're not approaching to a specific number. If you're going to go much closer to that of a number 0, the output could be in million, billion, okay, negative million, negative billion, okay, negative trillion. So that means it's not a specific number. Similarly, if you are approaching 0 from right hand side, this is left hand side, this is from right hand side. If you're approaching 0 from right hand side, from this side, okay, for example, you are taking the value 0.1, then 0.01, then 0.001, you can see the function is generating an output value that's getting bigger and bigger. It's not approaching to a specific number, okay? It's not approaching to a specific number. The more closer we get, the bigger output we are getting. So from the table and that of a graph, the function fx becomes unbounded as we approach, or as we get closer to that of a value 0. Or we can see that fx is not approaching a real number. Why I'm saying this is because you're not getting a particular specific number. The number is changing. The more closer you get, the number is changing. Okay? In the first case, it's getting smaller and smaller and smaller. In the second case, it's getting bigger and bigger and bigger. So we can see that from the left hand side and right hand side, the limits are not equal, so limit does not exist for this. So one more important trigonometric limit we have to find. For example, if you want to evaluate limit for a function fx equal to sine x by x, you will have to evaluate the limit at x as x approaches to 0. We know that we cannot evaluate the value of this function as at 0. The reason is function will be in the form 0 by 0, which is undefined. So for undefined, we cannot predict what the output is. Okay, so what we're gonna do is, if you want to find the limit, you will approach to this value of 0 either from left hand side and right hand side, and you will see and you will observe how the function behaves, how the function behaves, what output it generates for us. Unlike in previous examples, we could have used algebra and we could have simplified the expression and we can find the limit, but not in this case, because sine x by x cannot be simplified. I will give an example. For example, in previous case, let's suppose we have a function fx equal to x squared minus 9 divided by x minus 3, and we want to find limit of this function as x approaches to 3. So we know that at 3 it becomes 0 by 0, which is undefined. Okay, if we simplify it, it can be written as x minus 3, x plus 3 divided by x minus 3. We can cancel it and we will get x plus 3. Now you can evaluate the function at x equal to 3. We'll put the value of 3 plus 3, that is 6. But unlike this expression, here in case of sine x by x, we cannot use algebra. So we will have to do it graphically, analyze it graphically and by the table. If I have drawn a graph of sine x by x, you can see that as you are getting closer to that of a value 0 from right hand side and from left hand side, the values that we are getting is approx equal to 1. We say that from graphically that the limit of this function is equal to 1 at x when x is approaching to 0. Here from the graph, from the table, we know that if you want to find, for example, limit, you will have to take, for example, you want to find limit at 0.1, you will take sine 0.1 divided by 0, and you will find the corresponding values, and you will find the value a. If you simplify it, it will be 0.9983334. Similarly, as you're approaching 0 closer and closer from left hand side, we are getting a value that's getting closer and closer to that of 1. As you're approaching from right hand side, we're getting a value that is getting closer and closer to that of a 1. Okay, so from the table and the graph, it leads us to conclusion that limit of function as x approach to 0 from right hand side is equal to 1. A limit of this function as x approach to 0 from negative side is equal to 1. So we can say that limit of this function as x approach to 0 is equal to 1. Thank you. Hope to see you in next lecture.